An equation is a statement written in mathematical terms. For instance, this sentence could be expressed as an equation by placing an equality sign for the word is. Most mathematical equations use numbers and letters instead of words. Letters used in an equation stand for a variable. Some equations have only one variable, while others may have two or more. Comparing an equation to a balance, we can see that all equations are essentially the same. There is a left side and a right side, and the equality sign in between states that the two sides are equal or balanced. However, just as a statement can be true or false, so can an equation be true or false. The equation x plus 2 equals x plus 1 plus 1 is always true no matter what number is substituted for the variable x. An equation which is always true is called an identity.
Identity.
But the equation x equals x plus 1 is always false, regardless of what number we replace x with. An equation which is always false is known as a contradiction.
Contradiction.
Then there are some equations which are true sometimes and false sometimes, depending on what numbers are used to replace the variables in the equation. Equations which are true sometimes and false sometimes are called conditional equations.
Conditional.
Most of the equations students work with are conditional, and the student is often asked to solve it. There are 4 operations that help us solve an equation. We can understand these operations best by going back to the balance. Although there are 4 basic operations, they are all based on the same principle. And that principle is that as long as you do the same thing to both sides of the balance, its position remains the same. If you add, subtract, multiply, or divide the same amount on both sides, then the position of the balance remains the same.
Divide.
Like the balance, as long as you do the same thing to both sides of an equation, the resulting equation will be equivalent to the original one. If on both sides of an equation you add the same number, subtract the same number, multiply by the same non-zero number, or divide by the same non-zero number, then the resulting equation will be equivalent to the one you started with. Obviously, the numbers used in an operation are not picked at random, but rather are chosen to arrive at a desired solution. Here's an example. Let's solve this equation for the variable x. We can solve it by using the 4 operations. Our first objective is to get all the x's on one side of the equation and all the numerical values on the other side. In order to get the numerical value 2 from the left side to the right side, we can add 2 to both sides.
Add.
The negative 2 and positive 2 cancel each other out on the left side. On the right side, we can simplify by adding the 4 and the 2 together to get 6. Now, in order to get all the x terms on the left side, we subtract 2x from both sides.
Subtract.
We can see that the 2x and negative 2x on the right side cancel each other. Now that all the x terms are on the left side, our goal is to find out what x is equal to. Let's multiply both sides by 2 to eliminate denominators.
Multiply.
The left side can be expressed as 2 times 7x divided by 2 minus 2 times 2x. Simplifying further, we find that 2 times 7x divided by 2 equals 7x, while 2 times 2x equals 4x, and the right side is 12. We can even go a step further and simplify the left side, since 7x minus 4x equals 3x. Finally, to solve for x, we can divide by 3.
Divide.
The left side simplifies to x, while the right side becomes 4. We have found the solution for x. As you begin working with equations, you will find that there are many different kinds. This unit has to do with linear equations. The distinctive characteristic of a linear equation is that all the variables are to the first power. For instance, although these three statements are all equations, only one of them is a linear equation. The first one is not a linear equation because the variable y is to the second power. The second equation is a linear equation because both x and y are to the first power. The third is not a linear equation because 3 divided by y is the same as 3 times y to the negative 1, so the variable y is not to the first power. Formulating equations, whether they are linear or another type, can be very useful in solving common problems. When studying a certain subject, a person will often discover a pattern that can be expressed as a statement or equation predicting a given result. Let's look at a common problem to see how it can be solved using linear equations. Let's suppose you are a clerk at McGinnis Drugstore. You have been asked to price several items to be put on shelves, and your boss tells you the retail price is the cost plus 25% markup and 3 cents for handling each item. You might begin by figuring the markup and adding the cost and markup together for each price and then adding 3 cents. However, eventually you might discover that there is a uniform relationship between the cost and retail price. If you were to graph this relationship, you would see that it graphs as a straight line. This gives you a clue that your problem could be expressed as a linear equation, since linear equations with two variables are graphed as straight lines. So you decide to formulate the problem as an equation. Your problem can be expressed like this. Let's let x equal the cost of an item in cents. Then the markup on it equals 0.25x in cents. Now let y equal retail price in cents. The two variables in this problem are x and y. The retail price could be written as the equation y, the retail price, equals x, the cost, plus 0.25x, the markup, plus the 3 cents handling charge. We can make the equation more compact by combining x and 0.25x so that y equals 1.25x plus 3. Now to determine the retail price, you need only multiply the cost by 1.25 and add 3 cents to it. And this equation can serve as a handy formula for computing the retail price of any item. In this unit, you will see many linear equations which help solve everyday problems. And if it weren't for man's ability to use equations and develop formulas to solve problems, he'd never get off the ground.